Okay, let's take the first question. And if they ask you to find the angle of friction, can you find angle of friction? What is the relation between angle of friction and coefficient of friction? You know, there's a relation between angle of friction and coefficient of friction. Let's try to write this, and then we are starting with the question. Relation between angle of friction and coefficient of friction. Angle of friction and what is angle of friction? You know what is angle of friction? And coefficient of friction we studied just now.
Yes, sir.
So what is the relation between angle of friction and coefficient of friction? What is the angle of friction? Let's say if an object is kept over here like this, what will be the angle of friction? The angle of friction will be this angle. Let's say the mass of this object is m, it will be mg. It is the normal reaction. Okay. And here we can have the contact force. You remember what is the contact force? Let's say this is the contact force, and friction is basically the horizontal component of contact force. Can you recall this? Friction is the horizontal component of contact force. This is the friction. Let me draw it from here. This is the contact force. The horizontal component of contact force is friction basically. Okay. This is friction. Horizontal. Now this angle is angle of friction between the normal and the contact force. Okay. This is angle of friction. Now there is a relation between angle of friction and coefficient of friction. So what is the relation between angle of friction and coefficient of friction? If this is the angle of friction, then we have where theta is, I'm writing it over here, it is angle of friction. Theta is, any problem? Yes? What is? Nee, this is the contact force. Actually your voice is not coming properly. See, this is the contact force. This.
What is the contact force? Is it the force which applies on the body?
Yes. Let's try to understand what is the contact force. I told you that these surfaces on microscopic level, they are like this. And when you keep an object over here, let's say it will also have irregularities like this, and you keep an object over here, what will happen? This surface will apply a force on it. The force will be an arbitrary direction likewise. Okay. These are the forces because it is in contact with this surface, no? Is it this surface, this irregularities are in contact with this surface like this. Okay, so what happens generally? How can we have a normal force like this every time? This is the normal component of the contact force. Every time we do a normal reaction, how it can happen? There are see, let me draw it one more time. There are irregularities between these surfaces like this. Let me draw it. When they are having irregularities, okay, anything which is kept over, suppose if an object is kept over here, let me not draw the irregularities on this surface because it is making a little bit confusion. Let's take, I am having an object like this kept over here. Now what will happen? This surface will apply a contact force like this, and in any arbitrary direction because it is in contact with this, because the surface is not smooth, not normal, na? So wherever we are having a contact force like this. The contact force either is in this direction or some arbitrary direction. Are you getting this thing? Because this is applying a force on it. It is supporting this. There may be some force in the upward direction. That's why it is over here. Otherwise it will fall down. So this is the contact force. Now what is happening when you are drawing this contact force, let's say it's F or whatever you are mentioning, there is one component of contact force which is normal to this. We are calling it normal reaction. Are you getting this thing? That's why every time this normal reaction is perpendicular to the surface. How this can happen? Just because one component of the contact force, we are calling it normal reaction. And the other component of the contact force is this is the horizontal component of. So friction is basically what? Let me write it over here. Yes, I think I have explained you all these things before, I think, but you have forgot. Friction is basically the horizontal component of contact force. Are you getting this thing? Horizontal component of contact force. Okay. The one component of contact force is normal reaction and the other component is friction. Are you getting this thing? This is the normal reaction is one component and horizontal component of contact force is friction. So this is what is friction basically. And the normal component of contact force is normal reaction. Normal, because it is normal to the surface, we can see. Component of normal component of contact force is normal reaction. So this is what is there. Okay. So now with this basic idea, now we have to understand what is the relation that we have not written. This is angle of friction and all these things. We have to write the relation between angle of friction and coefficient of friction. Let me write this. Can I write this? Okay. So we have drawn this diagram over here. This is the contact force. You can write it over here. This is the contact force, basically. Okay. This is the friction force which is coming, and this is normal reaction. This is normal reaction, and this is friction force. So this is the basic idea. Now you can see over here the relation between angle of friction and coefficient of friction. So what is the relation between angle of friction and coefficient of friction? If theta is angle of friction over here, this angle is the angle of friction. So now what I can write? I can write tan theta is equal to mu, where mu is the coefficient of friction. Okay, it can be kinetic friction or it can be static friction, any. So I am writing mu only. So mu is the coefficient of friction and theta is the angle. Let me write over here, mu is the coefficient of friction. So mu is coefficient of friction. So what is the value then? Tan theta is equal to mu. So this is the relation between coefficient of friction and angle of friction. They may ask you to find the coefficient of friction, the angle of friction, anything they can ask. Okay. Note it down. Shall we move to the question now?
Yes, sir.
Okay. Can I rub this?
Yes, sir.
Okay, now we are moving to the question. The first question it is saying a force of 49 Newton is just sufficient to pull a block of wood weighing 10 kg on a smooth horizontal surface. Calculate the coefficient of friction and angle of friction. Okay, but let's not do this question first. Let's take some other question. Then we will come to the second question. We'll come to this. Shall I rub this? I am rubbing it and now writing the question. So now the first question says a block of mass 2 kg is placed on the floor. Question says a block of mass 2 kg is kept on the floor. Okay, so a block of mass 2 kg is kept on the floor. The coefficient of static friction they have given. Now they are saying coefficient of static friction means the object is at rest. They are not saying the object is moving or not. They are simply saying the coefficient of static friction is this. That means the object is at rest. The coefficient of static friction is what they are giving. They are giving it 0.4. Now coming to the next part. What they are saying, a force of friction of 2.5 Newton. A force, calculate the force of friction between. Okay, so what they are saying, this is what they are given. Calculate, they are asking calculate the force of friction. Calculate the force of friction. Okay. So what will be the force of friction? You think? So what we will do? See, the situation is. See, the problem is. We know if the object is at rest. If the object is at rest, the friction force is a self-adjusting force, isn't it? It may be 0, it may be some other value. The maximum value of it can attain is that is the limiting friction, isn't it? So what we will say, they have not mentioned anything. They have not mentioned anything. How we can say? Suppose if we are not applying any force, the friction force is 0. So what we will do, we will write the value of limiting friction. That is the maximum value of static friction. Isn't it that we can calculate only? Okay, so we'll write it.
So we can only calculate the value of limiting the friction.
No, let's see how it is. Because it's a self-adjusting force. That means if I apply a force of, let's say, 4 Newton, friction will be also 4 Newton. See, let's try to find it out. First, let me calculate the value of limiting friction. The value of maximum static friction, or we can say value of. We will write like this: value of maximum static friction, or value of limiting friction. Okay. So what will be the value of limiting friction? Yes, I am writing it friction as mu times. They have given coefficient of static friction. That means mu. In the question, what they have given? They have given this thing. That mu s is equal to 0.4. And what else they have given? They have given mass of the object as 2 kg. And they have not mentioned about the acceleration due to gravity. So we will take the acceleration due to gravity as 9.8. Is it okay? Yes? No, what sign convention? There is no sign convention here. No, sign convention, we have to take sign convention. But here, my object is not moving in the vertical direction. When they see, why we take sign convention? Suppose my object is moving in this direction. This is the direction of initial velocity. And the G is acting in this direction. That time we take the sign convention. Where two things are moving in the opposite direction. If this direction I consider positive, this direction is negative. Here it is at rest, nothing is moving. So there is no sign convention. I'm taking this direction as here also we have to take the sign convention. I'm considering this direction as positive. That's it. The problem arises where one object is moving in let's say object is moving in this direction and acceleration is in the opposite direction. Then the problem arises. Because that acceleration is acting in the opposite direction, that is a negative acceleration that is going to de-accelerate it. We need to understand all these things. There is a different situation, isn't it? If the same object, let's say if the same mass is over here and it is falling down, then what will be the value of g? If the same object is over here, it is falling down, what will be the value of g? It will be positive, isn't it? See, while this object is going up, the value of g is negative. While it is going down, the value of g is positive. So let's come here. The value one. Okay. Now it's okay.
Yeah, it's fine.
Okay. So now let's. What I was explaining is, if I consider this example, while this object is going up. While it is going up, the g is in this direction. It will be negative because it is opposing its motion. While this object is coming down, it is moving in this direction and g is in also this direction. That means it is supporting the motion there. Speed is increasing. Acceleration is g is positive over here, and here it is negative. And here the object is not moving. Nothing is happening. So we can consider g as positive, isn't it? So now come to here. We can find the maximum value of static friction. We can write it the maximum value of static friction, or we can write the value of limiting friction. So what will be the value of limiting friction? We have already discussed. It is mu times normal reaction. And as you can see over here, as you can see from here, this object, let's say our object is over here. I am considering this as my object, and let me draw the forces on it. Can we write? Yes, what are you saying?
No, sorry. Shouldn't it be mc equal to mg because it is like this?
Yes, it will be same. Now let's see over here. Even if it is moving, then also it will be same. It is mg over here and normal reaction over here. See, we need to understand the very basic concept. Friction is always mu times normal reaction. It's normal reaction. Okay. And normal reaction, every time it is not equal to mg, isn't it? Do you think every time normal reaction is equal to mg? No. Sometimes it maybe have apparent weight and all these things. There, this normal reaction will change. Okay. So suppose if you apply some force from the downward, what will happen? This normal reaction will fall, and hence the friction will also fall. Friction depends on the weight of the object. If you keep one more block over it, what will happen? Friction will increase or decrease? Suppose I am having one block over here. I keep another block over it. What will happen to the friction? It will increase. It will increase. Why increase? Because the normal reaction is going to increase, isn't it? Now I am adding one more block, means I am pressing these two surfaces with more force. And when you press these two surfaces with more force, the interlockings, what we discussed before, they are going to lock very tightly. And now it is becoming more difficult to move them. Isn't it? This is what is happening. So if you increase the weight, if you increase the normal reaction, the friction. See, friction is directly proportional to this normal reaction. You increase the weight of the object, the friction will increase. So now let's come to here, and here if I come to this situation, here normal reaction is equal to mg. So just put is equal to mg, no problem. But we need to understand this thing, that why this thing is coming. Otherwise, the question may change and you will not be able to get the right answer. So I write this like this, mu times mg. Now put the value and find the answer for friction. What is the value of mu s? It is 0.4. What is the value of mass? It is 2 kg. And what is g? It is 9.8. Okay, let's take it 10. Yes, 10 meter per second square. Let's take it 10. So it becomes 20. Yes, 20 into 4. It's how much? Yes, it is coming 8 Newton. So friction is equal to 8. Maximum value of static friction is 8 Newton. It's okay. Let's say I'm talking about this block. This was my block. Let's say I'm not applying any force on it. What will be the value of friction? I'm not applying any force and it is at rest. What will be the value of friction? Yes, 0. If I apply a force of 2 Newton, let's say, then what will be the friction? Yes, 2 Newton. If I apply a force of 4 Newton, then what will be the friction? Yes. If I apply a force of 8 Newton, what will be the friction? Yes, again 8 Newton, because the maximum it can apply is 8 Newton. This is the maximum value of Newtonian friction. And if I apply a force of 10 Newton, then friction, what is the value of friction force? Yes, still 8 Newton. Now when I apply 10 Newton, it will start moving. It will happen with a force of 2 Newton over here, it will start moving. And what will happen? Once it starts moving, now interlockings will reduce. Interlockings will not get enough time to, irregularities will not get enough time to interlock. Now what will happen? Then the friction, nature of friction will decrease. Then this coefficient of mu s, it will change to coefficient of mu k. Now the coefficient of mu k is somewhat less than this. Now what will happen? Which was earlier, the maximum static friction was 8 Newton. Now the nature of friction has changed. The friction has reduced a little bit. Now the maximum friction it can offer is, let's say earlier it was 8 Newton, maybe now it can offer 6 Newton only. Isn't it? Are you getting this thing? Because this coefficient of kinetic friction is less than the coefficient of static friction. The friction has reduced a little bit. Earlier it was giving 8 Newton while it was at rest. Now it has started moving, the friction has reduced a little bit. Now the friction has become less. So that's why once the object starts moving, even with some lesser force, we can move it. It will move. There is no problem. But when it was initially it was at rest, it was very difficult to move it because the friction was very high. The irregularities were completely locked. We were not able to move it. So this is the basic idea. Is it okay? So shall we move to the next question now? We are moving to the next. You have noted it down? Can we move to the next question? Okay, I'm rubbing it and now we are coming to the next question. Okay. Coming to the next question and let's see. See, the next question says a force of 49 Newton is just sufficient to pull a block. Question says a force of 49 Newton is just sufficient to pull a block. Weighing 10 kg of mass 10 kg. Okay, so this is what they are giving. To pull a block of mass 10 kg on a rough horizontal surface. On a rough horizontal surface. Okay, now what they are asking calculate the coefficient of friction and angle of friction. They are asking calculate the coefficient of friction and angle of friction. So can you find it out?
Yes, sir.
Okay. Let's try how we can do it. So how we can do it? We have just now decided that a force of 49 Newton is just sufficient to pull a block of mass 10 kg. This means what? That they have given the value of limiting friction. This is the value of limiting friction. It's just sufficient, isn't it? Let's draw the diagram over here. I am having a block over here. Okay? I am having this block. Now I am applying a force over here. How much force I am applying? I am applying a force of 40 Newton. And this is just sufficient to pull it. That means this is just sufficient to overcome the limiting friction. Isn't it? That means friction is acting on this side. And this force is just sufficient to overcome this limiting friction. That means the limiting friction is equal to this force. We have just taken example before. So that means our limiting friction is, I am writing it over here, the maximum value of static friction or limiting friction. This is the limiting friction. And what is its value? Its value is 49 Newton they have given over here. Now we know now what they are asking coefficient of friction and angle of friction. Now we know this thing. This is the coefficient of friction into normal reaction, isn't it? We know the formula. The formula is this. And in place of normal reaction, what I can write? This is mg over here. See, we have to draw. Every time we need to see that what is actually the normal reaction. It may be equal to mg or it may not be equal to mg, isn't it? Whatever the value of normal. Yes. Yes. They will give you the condition. Whatever the situation is there, they will give you. If the normal reaction is equal to mg, put mg. If it is not, then put that value. So we need to see the situation. Here the situation is normal reaction is equal to mg. So no problem, we can put the value. So this is the situation over here. Friction is equal to mu times mg. So now what we have to find? They have given that m is equal to how much? 10 kg. They have not given the value of g. Let's take it 10. Okay. Let's take it 10 for simplicity. Even if we take 9.8, then we can cancel this 49 with that. Can we take 9.8? Let's take 9.8 because we can cancel with that. So let's take 9.8 meter per second. Now you can see over here, they are asking to find what? They are asking to find coefficient of friction. Coefficient of friction means this. They are asking to find coefficient of friction and they are asking to find angle of friction. Angle of friction is theta, isn't it? So first we have to find this coefficient of friction and angle of friction. So coefficient of friction is over here. So mu s is equal to how much? This friction force divided by m into g. So now let's try to find out this friction force is equal to how much? It is equal to 49.
Coefficient of friction is just right.
This is coefficient of friction, isn't it?
That's coefficient of static friction. Right?
Yes, coefficient of static friction. They are asking. See, this is understood only. If the object is at rest, the coefficient of static friction. If the object is moving, then it is coefficient of kinetic friction. It is already understood, isn't it? Because we have studied all these things. Maybe they may be asked. See, they think that you understand all these things. That object is at rest, that coefficient of friction. So that's why they are asking like this. Okay. So you need to understand that thing. They may mention sometime in the question that coefficient of static friction. They may give or they may not be given, but it is understood. We have understood all the concepts. That if obviously it is at rest, coefficient of static friction. Obviously it is in moving, it is coefficient of kinetic friction. So with this, just put the values. What is the value of m? M is over here is 10 kg. And g I am taking 9.8. Why I have taken 9.8? Because I can cancel these numbers with 7. So I cancel with 7, it becomes 7, 7 and it becomes 7, 1, 1.4. isn't it? It becomes 1.4. Is it okay?
Yes, sir.
So this becomes 1.4, and if I remove the decimal, it becomes how much? It becomes 10 over here.
It's like 8.8.
Yes. It becomes 2 over here, and 10 will get cancelled. What I am getting is coefficient of friction is 0.5. So the coefficient of friction is 0.5, and the coefficient of friction is just a ratio only. It's a number. So it is not going to have any unit. It's just a number. So coefficient of friction I am getting how much? I am getting it 0.5. And it's a number, it is not having any unit. Is it okay? Why it is a number? Let's see. Why it is not having unit? Because friction is equal to, let's say, mu times normal reaction. And let's say why it is this is coefficient of friction. Let's say coefficient of kinetic friction or static friction. It is this friction force divided by the normal reaction. This is what it is. And we can see over here, this is a force, friction force, and this normal reaction, it's also force. So we are having force in the numerator, force in the denominator. It is the ratio of these two. It's the ratio of friction force divided by the normal reaction. Isn't it?
Yes, sir.
Are you getting this thing? See, let's try to understand one more thing over here. I said, if I am having a mass like over here, its mass is mg, it will have a contact force like this. Isn't it? Contact force. Let's say I am writing Fc, contact force. So what is the normal component of this contact force? It is N. And what is the horizontal component? It is friction. And what is this coefficient of friction? Coefficient of friction is basically this horizontal component divided by the normal component. Isn't it?
Yes, sir.
And this is the angle of friction. If I draw this angle, this is the angle of friction. And the coefficient of friction is basically this horizontal component divided by the normal component of this contact force. So this is the basic understanding. So we have find out over here coefficient of friction is this, and it is because it's a ratio of horizontal force, component of contact force, and normal component of contact force. They are asking you to find the angle of friction. What was the relation between angle of friction and coefficient of friction? It was like this: tan theta is equal to mu. Okay. If it is an object is at rest, it is static friction. Coefficient of static friction. If it is an object is moving, it is equal to coefficient of kinetic friction. It's okay. It's again understood. Whatever that coefficient of friction. So that means what I am getting, we have already calculated mu s. It is equal to 0.5. That means theta, I need to find theta. That is theta is obviously, yes, it will become tan inverse of 0.5. So this is what I am, yes. Okay, yes, we can leave it like this. So this is your coefficient of friction, this is your angle of friction. So this is what they have asked in this question. Is it okay?
Yes, sir.
Okay. Shall we move to the next question now?
Yes, sir.
Okay. I'm coming to the next question. Okay, we are coming to the next question. So, when you want to take next class, you want to take?
Tomorrow I will see.
Okay, tomorrow we can have next class. At 7 p.m. 7, can you do at 7 p.m. IST or any other time?
So 7 p.m. IST is fine.
Okay, so tomorrow we will do at 7 p.m. IST. So, shall we move to the next question now?
Yes, sir.
Okay, I'm moving to the next question and let's see what we can do in this. So now the next question, we are taking a question. Let's say the mass of A and B are 10 kg and 5 kg respectively. Let's write that question. There is a diagram also. The mass of A and B are 10 kg and 5 kg. Respectively. Okay, this is what we are saying. Respectively, calculate the minimum mass of C. Calculate the minimum mass. So what they are asking, calculate the minimum mass of C which may stop A, which may stop A from slipping. This is what they are giving. Now again, coefficient of static friction between A and the table. Coefficient of static friction between A and the table. A and the table. So coefficient of static friction between A and the table is what they are giving? They are giving it 0.2. Okay, now let's draw the question. It is a diagram. It's a little bit, you can see it's a, see we are having a table like this. Okay, the table is like this. Let me draw it a little bit down. Here we are having a table like this. And in this table, there is one leg of the table over here. And in this table we are having a mass over here. Let's say this is the mass. Okay, now this mass is A. This is A mass. I'm writing it A over here. On top of it, there is one more mass which is kept. And this mass is known as C. Okay, this is C. And what is the another arrangement? There's an arrangement like this. There's a pulley over here and one rope going over. There's a pulley over here. Let's make it a little bit bigger. There's a pulley over here, and along with that a rope is going on, and there's a mass like this. Is it okay? So this is my mass B, this is my mass B, this is A and this is C. It's okay. See, it is looking difficult, but it's not that much difficult. Okay. Now let's try to understand. This is the situation. You got this situation? What is the situation? See, what they are saying, the mass of A and B are, this is how much? This is 10 kg. Okay. This is, now let's try to understand question quickly. This is 10 kg. This is 5 kg. Okay, no problem. So now what is happening? This is of 10 kg and this is of 5 kg. Let's remove this. What will happen? It's a simple arrangement. 5 kg block over here. There is some friction between these two surfaces. The coefficient of C. Calculate the minimum mass of C. What they are having? Here we are keeping a block over here. Just now I told you that if I am having a block over here like this, okay,